Welcome to clickmyproject.com. Here we are going to see the receiver autonomous integrity monitoring of GNSS signals for electronic toll collection. Global navigation satellite system is the measure of the trust that can be placed in the satellite positional updation function. The GPS based monitoring systems are positional based one. So if the position of the vehicle is shifted to some of the untracking region, then the estimation of vehicle monitoring is difficult. For that purpose, the GNSS based system integrity monitoring is proposed in this paper. The concept of GNSS integrity is originally developed in civil aviation framework of the International Civil Aviation Organization. Is in this organization the several constraints for the GNSS based estimation also described. The electronic toll collection from this system is analyzed and the vehicle monitoring is also analyzed in this paper. Next we are going to discuss about the architectural diagram of proposed system. It consists of 6 blocks: positional initialization, GPS location based simulator, base station frequency initialization, DWT based feature extraction, ANN classifier, and the analysis performance. Positional initialization. The positional initialization, it shows the position of Stanford GPS platform SGMP tool. It is the tool that helps us to GPS measurements. The components of this tool are measurement interface, GPS simulator, user interface. The measurement interface, the supported formats for data sets to the MATLAB function is declared here. After this positional initialization, the GPS location based simulator identifies the simulated performance of signal strength and signal estimation here using various functions: postfix functions and batch postfix functions and positional fix function. The function of executing the positional is done using the SGMP file. Base station frequency initialization. The base station frequency initialization, it shows the initialization of 2 frequencies such as 95 to 100 GHz range for the base station, and the frequency of the signal received to the base station is 1 to 5 GHz, which is also initialized in this block. DWT based feature extraction. After initializing the frequency, the DWT based feature extraction, which applied to the signals from this module, we can get the position of vehicle and also the updated factors of the vehicle. ANN classifier. Using this ANN classifier, a proper tuning is to be adapted for this ANN classifier to get the estimation of positional errors and the fixed position of the vehicle, because the vehicle is moving in random direction in any way. So the identification of vehicle movement in a particular direction captured by using this process. Comparative analysis. This analysis shows the comparative performance of GPS and GNSS based location, that is location based simulator and signal based simulator. The accuracy performance also analyzed in this module. So overall performance is GNSS based system performed signal based effectively. Next we are going to discuss about the running procedure of our proposed system. This consists of several functions: main function, positional fixed function, and pairs estimation and parameter estimation. GNSS main function, this is used for signal based estimation technique and the frequency M generation and discrete wavelet transform and positional fixing generation, that are all carried out in a same folder. Now I run the main function. This function is the initialization parameters of several calculation, that is GPS based location signal strength is evaluated using this block, and also the positional estimation, the signal strength calculation, the amplitude level of the received signal and base station signal are displayed in this function. Now I run the function. So this function shows the three blocks: GPS initialization, GPS simulator, GNSS signal based tracking. Now I run the first module, GPS position. So this extract the default positions which is to be parsed to the separate folder. In this folder, after the extraction of positional, we can update the signal estimation for each position. So 100% achievement, that is 24 number of data sets, or that has to be parsed to the separate folder. So 24, after 24 data are parsed, the simulator will be start. So GPS simulator, I run the simulator, then the positional estimation starts here. Using this positional estimation, we can calculate the geostationary positional value. So this figure shows the signal amplitude level of 4 direction, north, east and up values. Positional error, by drawing the positional error and up amplitude, north amplitude, east amplitude estimation, we can estimate the values. This is the three-dimensional view of the positional tracking for different number of sets, and this is the radiation pattern for this signal, and this is the amplitude level for each time values that has to be displayed in this window. Now I run the proposed work, GNSS signal based tracking. So this shows the subfunction called GNSS main function. After the base station frequency initialization, this plot shows the amplitude level of the received signal for each number of base stations, that is booth number specification. This is the base signal of booth number amplitude with the time values. So this window shows the different booth numbers are randomly oriented, and this is the roadway block. This consists of base station. Now I run the signal strength calculation. This signal strength window shows the signal strength of each base station with received signal and also base station signal. And this is the signal which shows the base station randomly generate the signal value, and this red color dot, it shows the vehicle movement. Now I stop the movement. This is the history path of the vehicle movement that has to be displayed in red color line. When you click this button, the DWT feature of this vehicle position for the history path is displayed in this window. Now I find the position using this point. This point shows the ANN classification and the future points of the specified vehicle movement. So the ANN classification shows the vehicle position in roadway. If the vehicle is captured in booth number, means it will display the corresponding booth in that window. This is the cumulative distribution of error distance for the existing and proposed. The cumulative distribution function is maximized for particular error distance. And this is the accuracy analysis of existing and proposed system. Using this, the number of station and Wi-Fi frequency is to be fixed, and the accuracy in percentage is evaluated for the existing and proposed. That is, that they are also compared in this window. From this analysis, the proposed accuracy is maintained across the 90%. Thank you.